Hello. If the title of the video and the title of my channel don't already make it obvious, I'm Louis Roberts. I'm a GCSE and A-level math and physics tutor. I've been doing that for about 4 years since I finished my A-levels and while I've been studying at university. And in that time, I have done a lot of past exam papers with a lot of students, and I typically feel, confident in my ability to answer those questions. But no one's perfect, and I admit as much to my students. And so I thought it would be an interesting experiment to go to the most recent GCSE past papers and see how well I could do, hopefully in the same conditions that students would take them in. So this is paper one, non-calculator. This is the Edexcel Maths GCSE from 2023, which is the most recent one I've been able to access. And I'm not going to be using a calculator, obviously. I am going to be using Paint to do any diagrams that I might need to do, which I don't really feel like is cheating, to be honest. I'm going to be doing it within an hour and a half, which is the time limit for this exam. And obviously, I'm not going to be Googling anything, so I think I'm going as close as I can to exam conditions. Um, I'm going to record all of this in one go, so I might stutter. There might be a bit of silence. I know dead air is a crime, so I'll be doing my best to continue. I'll have a commentary going through the exam, but I obviously don't want to speak so much that I end up uh, taking longer than 90 minutes. And I don't think anyone wants to watch a 90-minute video of me doing this. I hope to do it in probably about an hour. I think that's what I would do back when I was in high school, so hopefully. Anyway, this video is going to be long enough, so I will start the timer now, which hopefully should be appearing on the screen. Yeah, okay, right, let's go. So, work out 6.3 times 2.4. Okay. So, I'm just going to keep the questions numbered just to sort of keep it all, whatever. And I'll just sort of try and title each question with however much detail is necessary. So I'm going to use the grid method, and I could do this in an exam, so I don't see this as cheating either. I'm going to sort of draw a table. I need to make it this big and this big, and I'm going to do this and 6.3, well, and 2.4. So 6 times 2 is 12, 2 times 0.3 is 0.6, 6 times 4 is 2.4, and 0.4 times 0.3 is 0.12. And then you're sort of supposed to do like a totaling up, aren't you? So 12 plus 0.6 is 12.6. Don't know why I stuttered there, to be honest. 2.4 plus 0.12 is 2.52. So that's going to be 14, so 15.12. And I'll just sort of, with every question, I'm going to put 15.12 as my. I'll put the answer in square. I've not pre-established this, so I'll put my final answer in brackets at the very end of the question. I think that's a good system. Okay. And then we're on to 2 AI, which is write down the value of 5 to the power 0, which is just, as I put it there, I need anything to the power of 0 is 1, so it's 1. AII, write down the value of 5 to the minus 2. I don't know how much detail I'm going to continue writing these question briefs in. So 5 to the, also I'll do some, like a mathematical purple line is going to mean I'm doing working out. 5 to the minus 2 is equal to, I'm going to do a little bit of latex maths just to try and keep all of the working out looking quite simple. It's 1 over 5 to the power 2. Obviously we know 5 to the power 2 is 25, so it's going to end up just being, I'll put this in brackets because this is my final answer. 1 over 25. Okay. And this is 2b. And I'll just write simplify because I don't need to go into that much detail. And this is 2 to the 5 times 2 to the 4 over 2 to the 3. So with powers of the same base, we can add add the powers when we multiply and subtract them when we divide. So it's going to be basically equal to, we can sort of simplify the numerator first. 2 to the 5 times 2 to the 4. I know the font's a little bit small actually. 2 to the 9. Oh, that's over 2 to the 3. And then obviously we can just use our rule again. I think I'll start writing it like this actually. 2 to the 9 divided by 2 to the 3. I think that's an easier way of looking at it. And this is going to be my final answer, so I'll put it in brackets. 2 to the 9 to the 3. Subtract 3 from 9, so 2 to the 6. Should be an equals there, shouldn't there? Okay. Move on to question 3. A is, I'll just say, prime factors of 156. This is going to be quite a hard thing to draw a factor tree in a note document, so I'll try and just sort of write it as a list, I suppose. We start at 156. God, this is non-calculator, isn't it? 156 is clearly divisible by 3 because 150 and then 6, so we can write it as 3, so it equals 3 times 52, yeah. Whether I know my factors of 52 now is another question. See, I've screwed up the format in here with the. Sorry, I'll start this. I'll go from the top. So 3 times 52. 52. This is where mental maths is genuinely my weak point. 26 times 2, isn't it? So 3 times 2 times 26. 26 is 2 times 13, so we can do 3 times 2 times 13. So I'll do 2 times 13. They're all prime numbers, and so it would be in the sort of nice simple form 2 squared times 3 times 13. Okay. B is find the highest common factor of 156 and 130. So here we're going to want to find 130 as prime factors, a product of its prime factors, and then see what's common in between those two lists. So I'll say HCF of 156 and 130. So let's go do the same thing for 130. So 130 equals 13 times 10. I'll do 10 times 13 because I want to keep the sort of prime numbers isolated. That's just 2 times 5, isn't it? Okay. So common factors between the two, we have, I'll say, common factors would be 1, 2, and 113. And so obviously that means that, should go back into math mode, therefore it's going to be 2 times 13. So I'll say the HCF of 156 and 130 is equal to 26. And I should preface, I am going to make a silly mistake somewhere in this video doing some maths, as we all do. And maybe you're going to be screaming at your screen. That's part of doing an exam. That's sort of, I'm being honest, I'm not going to clip together attempts at these questions such that I get them all correct. Maybe I do get them all correct, who knows. The mean length of 5 sticks is 4.2 centimeters. So that's just, I'm just saying something about means. I'm not going to go into the whole brief of what it is. So I can say something like this. Say L is 4.2 centimeters. And one of the sticks, just say L1, is 7 centimeters. Work out the mean length of the other 4 sticks. Okay, so we're going to assume that basically, yeah, very simple. So that when we're working out the mean, we do everything added together, and divide it by 5, and that would give us 4.2. So we could sort of say the mean length of the other sticks plus 7 divided by 5 is going to still equal 4.2. So I could write that as, I'm going to say L apostrophe, just to mean sort of the remaining mean, plus 7. Oh, and that's going to be 4 times that. There you go. That was close to making an early stupid mistake. I'll put that in brackets. I haven't been writing the final answers in brackets, have I? I should be doing that. So that's So I'll put the brackets outside of the math stuff. There we go. And then this was the final answer for this, wasn't it? 26. I can put brackets inside the math, so it doesn't matter that much. There we go. Okay, yeah. So that divided by 5 is equal to 4.2. So we can multiply both sides by 5, and we get 4 L apostrophe, the mean of L apostrophe, plus 7. Don't you need the brackets now because it's not a fraction anymore. So, and 4.2 times 5. Trick that I always use for this, multiply by 10 divided by 2, so 42, and then you go down to 21. Subtract 7 from both sides, you get 4 times the average of the 4 remaining sticks is equal to 14. And then we can just find, obviously, that the, I can say therefore, don't know what form they want me to give it in, to be honest. I'm not that informed on that, but there we go. It's 14 divided by 4. Would it be, do they want me to give it in a decimal? I'm not entirely sure. I feel like it's the safer option, so I'll say equals, and I'll brackets this 3.5 centimeters. I feel it's more likely to be the way they want it. I don't know, because they gave the initial answer as a decimal, didn't they? So now I made a mistake. The stick is not 7 centimeters long; it was 17 centimeters long. How does this affect your answer to part A? So they don't want me to do any working out here, as far as I can tell. They just want me to describe it. Just how does it's a 1 mark question. I don't think I need to go too deep. I can just say it will mean that the mean length of the other 4 sticks. Oh, hang on. The mean length of the other 4 sticks. Will the mean length of the 4 oh, this is one of those weirdly worded questions. Will the mean length of the 4 sticks stay the same? I guess from this from this information. Why is this messing with my head so much? Because like, oh, yes. How does this affect your answer? Because he thought it was 7 centimeters long, and he factored that into his calculations, and so from that, I don't think it does. Does it affect it? I don't think it does. Oh, but the mean length of 5 sticks, that's a piece of information given to us by God, not by Noel. Right. So the truth in it actually being longer is going to decrease the mean. Yeah, okay. I don't. That's probably what you would have got without thinking about it at all. But for some reason, I chose to go too deep on that question. The mean length of the other sticks is lower than calculated. Less than calculated is less than the answer to pi. Okay. Don't stress about the intricacies of these questions. He says knowing that question might actually be correct. Anyway, okay, this one's going to be where it actually might get a little bit. You question whether this is as difficult as it is or harder than it is for a student who's taking the exam. Because I know this requires a compass. Whether I can remember how to do this construction is a whole other question. So here we go. The point P lies on the line AB. Use ruler and compasses to construct an angle of 90 degrees at P. You must show all of your construction lines. Right, so it's very simple in that you would get your compass and you would then draw 2 arcs. Yeah, I think I'm correct on this. Let me just double check in my head. Do you draw? This is admittedly where I've forgotten some of the sort of required knowledge for this question. It's something to do with drawing an arc with P and A and with P and B. If you draw 2 arcs where your pencil starts at B, they'll never converge the curves except at P. If you draw them, like for example, and this is constructing a circle, perfectly doable for anyone obviously who's got a compass in the exam, so I don't think this is cheating. you do it with the point on B? Oh, this is. I don't think I'm getting full marks in this paper. With a ruler and compass. So do you measure? Yeah, no, okay. So you would measure, like say for example, 1 centimeter further than where P is from A. So in this case, I'm gonna have to use the pixel width of the circle. So it's currently, what's that? Is that 158? No, so it's currently 169. So I'm going to measure out, let's say, another 20 pixels to 189. And then obviously, because it's not going to be relevant, I can just sort of get rid of most of the rest of this circle, because I really should just be drawing an arc, obviously, in the question. With my immense skills in Microsoft Paint, that's going to be well easily enough. Then if you draw from here, it won't work well. That wasn't even a circle because it wasn't. I'm just. This is losing me immense amounts of amount of time. I want it. That's fine. I want it to be no fill. Okay. So yeah, measure from A to B. Maybe actually, is this a massive red herring? I'm convinced I'm doing the correct thing here. So starting from here, which is 169, I want to go to 189, and then obviously I want to actually make it a circle. So, but it needs to be symmetrical around the center. So 119, 70, and it adds 35 to both sides. This is so much harder than if you're doing it in the exam, in my opinion. 154, yeah, 154. And then that needs to go up to 189 now. If I've done it correctly, it should still be centered on the central line. And there's a big window they give you in terms of doing this. So, okay, yeah, 189. Okay. Actually, I'm just gonna leave these. It says leave your construction lines, so I'll pretend these are my construction lines. So then, if we create a circle of the same size, which we could do, if I had a ruler, I could very much find the point that's equidistant as A from P, and that'd be very, very easy to do. So there's no, I don't think you can describe that as cheating, to be honest. So we created an identical circle, and then we need to. So we started at 169, didn't we? So yeah, we need to just sort of do the same thing here. So we'll shrink this to 169 in width, then extend it to 189. Yes, and then we just look at these 2 points of intersection. I'll draw a line in red to make it very, well, you could only have blue in an exam, couldn't you? Let's be hyper realistic. Connect these two lines, and I think that's like a perfect 90-degree intersection there. So let's just save this. Not in the folder that wherever it's just gone, to be honest, where I actually want it to be in here. So that's question 5. Okay, that sucked up a lot of my time, it felt, to be honest. Okay, because we have an hour and 13 minutes left, so I really should be speeding up. The commentary's hurting maybe a little bit. Okay, the diagram shows an isosceles triangle ABD and the straight line ABC. BA equals BD, okay. X to Y is 2 to 1. Work out the value of W. Okay, so because ABD is an isosceles triangle and these are the two identical sides, I should be writing this down because it's my justification. ABD is how do you spell this word? Isosceles with AB, BD as equal sides. So that means that this angle here and this angle here are the same size. So that's BAD equals ADB. Okay, so, and that would be in this case x degrees. So we know that in the triangle ABD, we have 2x plus y equals 180 because angles in a triangle, interior angles add to 180, right? And we know that x to y is 2 to 1. That was if I didn't spot that, I would not be able to do the question. So that means that 2y is equal to x. And so to be more sort of useful in this case, yeah, we can say that x is equal to, is that correct? Yes, so that's y is equal to 1/2 x. And we can just substitute that into our existing equation. So that would be 180 is equal to 2.5. We need to get it in terms of y. I just realised to make it this much easier to do. 2y equals x. So that means that y is equal to 1/2 x. Now x is equal to 2y. Yeah, that's fine. I'm being stupid. So 4y plus y is equal to 180. And that just means, obviously, that 5y is equal to 180. And then divide both sides by 5. Again, sort of similar to them before. Divide by 10 multiplied by 2. 18 times by 2, 36. Y is equal to 36 degrees. Oh, it's y degrees, so y is equal to 36. And then we know that obviously angles around a straight line. Angles around a straight line add to 180. So y plus w is equal to 180. So w is equal to 180 subtract y, which is equal to 180 subtract 36, which is 144. I dropped the degree sign at points there, which is not proper exam technique, but I think it'll be fine, to be honest. Yeah, should be bracketing that, shouldn't I? As that's my final answer. Okay. Yeah, perfectly happy with that. Oh, it's W degrees. I don't even need to have degrees in the answer because of the way that it's stated. How many questions in the exam is a worrying number of pages for me to get through still? Okay. So Nano has 3 shelves of books. There are X books on shelf A. There are 3X plus 1 books on shelf B. There are 2X minus 5 books on shelf C. Total of 44 books. All the books have the same. Well, I'll answer that part of the question in a minute, to be honest. First question is, how many books are on each shelf? What's the value of X, for example? So X plus 3X plus 1 plus 2X minus 5 is equal to 44. I've completely given up, as you can see, start trying to title these questions because I know where the exam paper is. If I need to refer back, I can then collect like terms. X plus 3X plus 2X would be 6X. 1 plus minus 5 is minus 4. So minus 4 is 44. So that means it's 6X. Add 4 to both sides is 48. And then divide both sides by 6. X equals 8. Right, useful. All the books have the same mass. The books on shelf B have a total mass of 7,500 grams. Work out a total mass of the books on shelf A. So, how many books are on shelf B? 3x plus 1. I'll say books on B is equal to 3x plus 1, which is equal to 3 times 8 plus 1. 3 times 8 is 24, so that would be 25. So we can then sort of separately say 25 books is equal to 7,500 grams. Divide both sides by 25, and it's going to be 300 grams per book, which seems reasonable. Work out a total mass of the books on shelf A. So then book M, mass of books on A, is going to be 300 multiplied by just X. X we know already is 8, so 300 times 8, which is 2,400 grams, and I should bracket that, shouldn't I, as my final answer? Okay. Makes sense. About 3 times, a little bit less than 3 times. Yeah, perfect. Okay. Question 8. The normal price of a mattress is reduced by 40% of the sale. The price of the mattress in the sale is £660. Work out the normal price of the mattress. So we can just say that 660 is equal to 1 minus 0.4 of what we might call the normal price P, because 40%, 0.4, simple. So 660 is equal to 0.6p, and then we can divide both sides by 6. 110 is 0.1p, and then multiply both sides by 10, which would get us p equals £1,100. I will bracket that as well. It's the final answer. In exams, if you have a final answer and there's no line like this to put your final answer on, just underline it. I'll put it in like a big equal sign, like with the answer in between two horizontal lines. It's normally a nice clear way of denoting it. Question 9. To cook rice, the number of cups of rice x, so the number of cups of water is 4 to 5. So I'll just say x to y is 4 to 5. Use this information to draw a graph to show the relationship between the number of cups of rice and the number of cups of water needed to cook the rice. So we're extracting a linear relationship from a ratio. So the way we can think about this is that for every 5 y's, we need 4 x's to sort of have those as equal values in terms of amount of ingredient necessary. So because you need more y, 5 of them for every 4 x's, that means x is actually bigger. So we can actually then say, which is a bit confusing, isn't it? We can then say that that means that x is equal to 5 quarters, I should say, as British English. Y, but if we want it in a linear relationship, we should say y is 4/5 x. I do think that fourth makes more sense, but I don't really want to speak like an American. So 4/5 x. Yeah, let's take a screen grab of this, and I can plot it again using Paint. I think it's going to be as accurate as you could be using a pencil and ruler. So I don't think this is cheating. 4/5 x. So that just means we just mark like 1. We know it's going to be 0, 0 because it's got no plus c, and then we can literally just consider where we would be. So when we have x equals 5, we'd have y equals 4. And these graphs are always obviously really terrible for some reason. So I can just mark that point on there. X equals 5, y would equal 4. Just double check that was the case in the... Y is 4/5 x. Yes. When x is 5, y is 4. Yep. Could just draw a linear relationship now, starting at 0, 0, making sure it goes through. Should be using a more sharpened pencil, so nice thin line. Goes through that point here, and then just extends extends the graph. Should end up at 10, 8, right, to be correct. So yeah, there we go. It looks a bit weird in terms of where I've plotted that, but that's perfectly happy, and that's going to be question 9a. Okay. We'll just say, sorry, I should have denoted this as 9a, shouldn't I? Okay, on to 9b. Find the gradient of the line drawn in part A. I don't really know why you wouldn't have figured that out in part A, but yeah, it's just obviously very trivial. You can extract that y equals mx plus c. It's m there, therefore, so I'll put it like this: 4/5. Okay, and then C, I'll say BII. So this was BI, and then BII. Explain what this gradient represents, and it's going to be y was the number of cups of water. Yes, so it's the number of the gradient represents the number of cups of water one needs to add when adding a cup of rice. Just back check with what we initially started with. Cups of rice 4, cups of water 5. Wouldn't that mean you need 5/4 as many cups of water? Have I been stupid? think I have been stupid. 4/5. Why is 4/5 x? Yeah, I've extracted that data incorrectly. It's 5/4, 5/4 x. Don't know why. I think I again just sort of overthought that, overthought it. Yeah, so I have to replot it very quickly. Mistakes are perfectly natural parts of exams. Having to go, oh, I need to go and redraw something. Perfectly normal. So we're looking actually for 5 cups of water and 4 cups of rice. So this would be here. Yeah. And we just need to plot that exactly as we did before. Well, not exactly, obviously. 0, 0, up to here, it should be 8 and 10 as your sort of when you get to the edge of the extent of the graph. And then we're going to save that over the question 9a. Yeah. Obviously now we can just sort of cascade back through these these answers, sorry, 5/4 is the gradient. And this is still a correct answer, this is still true, even with the mistakes that I've made before. That's the end of question 9. Question 10. The circumference of a circle is 10 meters. Work out the area of the circle, give your answer in terms of pi. So we know that the circumference of a circle is 2 pi d. Sorry, it's pi d, so it's 2 pi r, is what I should say. And then we know that the area of a circle is pi r squared. So if we have the circumference, give your answer in terms of pi. Do you need pi? I wouldn't think you do in here, but I don't know. I'll try and do it the sort of nice, easy way. So 10 is equal to 2 pi r. So this would mean that r is equal to 10 divided by 2 pi. And then when you go into, oh, because you're going to square r now, yeah, it's fine. So then AC is pi r squared. And then it's going to be pi times 10 over 2 pi all squared. And you're going to cancel out, so the 10 on the top, you're going to have 100. You're going to cancel out one of the effects, it's going to be 4 on the bottom, and you're going to cancel out 1 pi, so it's going to be just over 4 pi. And the answer was given in meters, the initial thing, I mean, so it's meters squared is your final unit, and that is in terms of pi. And to be really unambiguous, obviously you should write it as like a vertical fraction, but I'm going to say, yeah, it's 100 divided by brackets 4 pi. And I should bracket that whole thing, actually, shouldn't I, as my final answer. Okay, I did not mean to put an asterisk in there. I just can't see my keyboard, seemingly. Question 11. Alfie recorded. I don't think there's any issue with me putting this table in. Do I need to, though? Oh, yeah, because I'm going to need to complete the table, aren't I? So it's probably very much worth putting this table in. I'll just say hashtag cars, least, lower quartile, median, upper quartile, and range. So least was 300. I've not even read the question, which is very bad practice. Okay, and we're completing the box plot and the table. Okay, so I will need to get this again. We'll make some simple deductions. So the least number is 300, so we need to plot that. So that's going to be, it's a box and whisker plot, isn't it? Is the sort of, seemingly don't refer to them as that anymore because I'm old, but there we go. 300 is this central thing here, and we should have it, the end of this whisker should be the same width or height as the box. It should then go right through there to your lower quartile. Should probably be a slightly thinner line, but who cares? The range is 1,000, so our maximum is going to be 1,300, which is here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, so this one here. Again, these bits of graph paper seemingly are always made to be as confusing as possible. Should be the same height as the box. Ish, you know, there's always allowances. And then down the middle again there. And then there should be a median thing here, yeah. So this should be 900. So 1, 2, 3, 4, 5. Peculiar looking box plot. There we go. This is question 11 AI. And this should be then AI saved as Q11 AI.png. And then AII, let's just say done, because it's going to be done here, isn't it? So lower quartile is, let's zoom in a little bit. So 800, these are 5 between each 100, so that's 20 per minor gradation, or what the word is. 780 is our least quartile, because it's 1 below 800. Upper quartile is 1200, that's rather easy to see. Completed the table, completed the box plot, yeah, because it didn't ask us what the maximum value was in the table. And on to part B. On some of these days, sorry, what's the question? Alice recorded the number of cars going into a village on each of 80 days. The incomplete table and the incomplete box plot give information about our results. Okay. On some of these 80 days, Alice saw fewer than 1,200 cars going into the village. Work out an estimate for the number of days Alice saw fewer than 1,200 cars going into the village. Right. So 1,200 being the upper quartile, that means that it's, if you go from minimum to maximum in the data set, that is 75% along the way. So I can say 1,200 is the upper quartile. Upper quartile is sort of includes the bottom 75%, 75% of data. We'll see. Upper quartile is more than 75% of data. Where the hell is my percentage thing? Of data? Yeah, so 75%. Days less than upper quartile is 75% of the data. And then we're just going to go, 75% of 80 days is just equal to 60 days. Okay, and that should be in brackets as the final answer, not should not be in asterisks. Don't even know what that does in this note-taking program. Is it? Okay, for some reason it really doesn't want me placing individual brackets as though I'm coding or something. Question 12. And we've got 54 minutes left. Okay, no worries. It's only used half an hour so far. And we are halfway through the exam, seemingly. Probably a bit more than halfway through. The straight line has the equation 2y equals 3x minus 7. Find an equation of the straight line perpendicular to L that passes through 6 minus 5. So when we consider perpendicular lines, it's that the gradients of the two lines multiply to equal 1. So that basically just means you can take the reciprocal of the gradient of a given line and it will give you the gradient of a line that's perpendicular to that one. So first we want to move this equation into the sort of standard y equals mx plus c form. You can do that by dividing both sides by 2, so that gives us y is, should we do this in maths mode, y equals 3 halves x minus 7 halves. And then we can see that the gradient is 3 halves. And so m perpendicular would be minus, sorry, it's not the reciprocal, I should correct myself, it's the negative reciprocal, so it's going to be minus 2 over 3. The two gradients should multiply to make minus 1 always. So that means that our perpendicular line would be something of the form y equals minus 2/3 x plus c. We don't know that yet, but we know that it passes through the point 6,5, and that basically just means that when x is 6 for this line, y should be minus 5. So we can just substitute in those ideas. So we can say minus 5 for y is equal to minus 2/3 multiplied by 6 plus c. So that's going to be, just to sort of simplify this down, minus 5 equals 2/3 times 6 is 4, minus 2/3 would then be minus 4. Take that out of the bracket, then obviously minus 4 plus c. What do you, without even needing, you just add 4 to both sides here to get c equals minus 1. And just sort of, you have to give the equation as the final answer. So this is going to be y equals minus 2/3 x minus 1. Okay. Question 13. Solid A and solid B are similar. The ratio of the height of solid A to the height of solid B is 2 to 5. The volume of solid A is 12 centimeters cubed. Work out the volume of solid B. So let's talk about scale factors. So we'll say, for example, we'll say length. We have A to B is equal to 2 to 5. So that means that to go from A to B in terms of length is to I think it's a weird way to write an equation, but it's multiplied by 5 over 2. That is your, in fact, let me sort of get rid of what I said before. The length scale factor from A to B is 5 over 2. Now we can relate the length scale factor to the area scale factor by squaring it, and then to the volume scale factor by cubing it. And that's this implication of similar shapes is that they have a consistent length scale factor. If you measure two lengths of the same sort of, if you measure the same length as in say the base width or whatever on two shapes, they should have that same factor if you then measure the height, for example, of both. Anyway, that means that the VSF, the volume scale factor from A to B, is equal to 5 over 2 all cubed. You do need to know, as far as I'm aware for this spec, the cubes of these numbers are 5 and 2. So this should be the VSF, sorry, it's equal to 125 over 8. So the volume of solid A is 12 centimeters. So to go from, so volume, we can now write that volume B is equal to volume A multiplied by the volume scale factor, unsurprisingly, of 125 divided by 8. And that is 12. We'll leave the units out for now, 125 divided by 8. We can simplify this now by doing 125 times 12 over 8. This is a perfectly fine way of working with these fractions. 12 over 8 is 3 over 2. Yeah, equals 3 over 2. So 125 times 3 over 2. And then half of 125 is 62.5. So that'd be 125 plus 62.5. I'm not going to try and stretch myself and make some stupid mistakes. 187.5 is, and it should be, of course, centimeters cubed for volume. And I should have that in brackets as my final answer. Okay. 48 minutes left, hopefully. I think we're getting towards the end of the paper now. I don't know. Work out the value of, I know I've been inconsistent with the with using the purple lines or not. I do typically use them. And it's 1/2 to the power of minus 3. Okay, so when we have a fractional indice, that basically is saying numerator take it to that power, and then denominator do that root. So I'm going to do the root first. That's equal to, is cube root even a function I can do on this? I don't think it is. I'm not sure if it is. Can I see CPRT? Maybe not. 27, and then that should be squared. Plus, if this probably won't work. And then negative indices mean take the reciprocal and then do the same thing. So it becomes 2 over 1, which is obviously just 2. That's 2 to the power of 3. Cube root's not a thing. So I will just do, yeah, I'll just write it myself. Cube root is 27, all squared. And then 2. So 27 is 3 cubed, so it's going to be 3 squared plus 2 to the 3. We need to know these off by heart for this GCSE, so that's 9 plus 8, and that's equal to 17. Okay. An object falls from rest. Here is the distance time graph for the distance d meters, followed by the object t seconds after it starts to fall. We've got distance in meters on the x-axis, time in seconds on the y-axis. Work out an estimate of the gradient of the graph at time t equals 3. You must show how you get your answer. So we're going to use the tangent method to find a gradient here. So we're just going to draw a tangent to the curve at t equals 3, and then compute the gradient of that tangent. And a really important thing is we need to use the full extent of the graph when we're drawing this tangent to get the most detail. And again, this is something I think is perfectly possible in the exam, what I'm going to do now. So I would not consider this any form of cheating. T equals 3. So around here, and we're just going to try and line this up. This is, I mean, obviously this would be the process of wiggling your ruler around to try and find this nice tangent in the exam. And what I'm doing right now is very similar to that process. I believe that's pretty much, if I go like this, is that pretty much tangent at 3? I'd say that's more tangent up here, so I need to sort of go further that way and further this way. Like that. Is that tangent now at 3? I'd say that's now tangent a little bit early actually, so need to go a little bit up there and a little bit along there. Don't waste too much time doing this. I think that's close enough, to be honest, that we'll get a good. It's a little bit off to the side, but I think it's close enough that you'll get the correct answer. So let's annotate this very quickly. That's 1.123. Well, we only need to go to one decimal place to get sufficient detail here. This obviously at the end is just going to be x equals 7. I don't even know why I needed to label that, to be honest, but there you go, I don't. So, and this is y equals 150. So this is so it's 10 in between, so it's 5 each. So that's going to be 150, 145, 140. Okay, so this is going to require sort of one of those ones where it's a diagram and is this question 15? A diagram and some working out. Q15. Okay. I'll try and keep those. I'll keep those actually next to it so I can see what I'm doing. So, velocity is equal to dx. Sorry, it's change in distance divided by change in time, or at least that's average velocity, right? Our point estimate in this case. So, change in x would be from 0 of this red line, from 0 up to 140, and change in time is from 1.3 to 7. So it's going to do 7 subtract 1.3, and is this supposed to be in? It's the word estimate is used, isn't it? I'm convinced. Estimate, yes, we can make some simple changes if necessary. 140, 7 minus 1.3 would be 5.7. Right. Now, I'm trying to think what multiples, to make this an easier division, we can think of a multiple of 0.7, right? So 4.9, 5.6. Yeah, so if we say that it's 5.6, yeah, we'll say, sorry, we use approximately equal to 140 divided by 5.6. And when I say equals here, I mean equal to what this term is here, which is approximately equal to the answer that we should have. 140 divided by 5.6, so that would be 1400, equal to 1400 divided by 56. 1400 is 7 times 200. And 56 is 7 times 8. We can obviously cancel the 7s, so it's equal to 200 over 8. 200 over 8, 100 divided by 4 and then that is just 25, and the answer should be gradient of the graph. So gradient of the graph does not necessarily, we don't have, do we give the units? I think we do, just to be perfectly safe, and that would be meters per second. It's the velocity, and I think that'll be the next question if I had to guess. Maybe like does it not even ask it? No, it doesn't. Okay, so the gradient, yeah, you should give the definitely give the units there actually for that gradient. And then I should be putting this in brackets, shouldn't I? Actually, I sped through that question. 41 minutes left on the clock. I'm not sure that a 1 hour finish is now possible, to be honest, but there we go. Calculator papers, I think, always take a bit longer. Non-calculator, sorry. At the start of the year n, the population of a species is Pn. At the start of the following year, the population of the species is given by, let's do this, Pn plus 1 is equal to Kpn, where K is a positive constant. Population of the species at the start of year 1 is 8 million, start of year 2 is 6 million. Work out population of the species at the start of year 3. So we could just say, substitute in these values, because P1 in this case. So I can just say, I'll just say P1 is equal to 8. We're in units of millions here, so we actually don't even need to write million in terms of getting the right answer. As long as you remember sort of in your back of your head that it is a million. So P2 could go Pn plus 1, P1 could go Pn, where n is equal to, sorry, I'll just say where n equals 1. We then have 6 is equal to k times 8, and therefore k is equal to 6 divided by 8, which is just equal to 3/4. So k is 3/4. Work out population of the species in year 3, and we can just sort of extend that and say where n equals 2. Shouldn't have put that in maths. Where n equals 2, we have P3 is equal to 3/4 times n, sorry, P2. We know P2, of course, to be 6. So 3/4 times 6 would be 18 over 4. And then that's 9 over 2 equals 4.5 million. And that's the final answer there. And that was, sorry, I didn't even notice, to be honest. 16A. 16B, at the start of year 5, the value of k is increased by 0.3 to a new constant value. Louise thinks that from the start of year 5, the population of the species would increase year on year. Is Louise correct? So k used to be 3/4 or 0.75. When we update it in year 5, k, the new k apostrophe, would then be 1.05. So we're now multiplying that population every year by a number bigger than 1, and therefore the population will increase. Yes, because now k is greater than 1. And it's a 1-mark question, so I'm not sure I need to write this down, and multiplying a number by a number bigger than 1, greater is the correct term I should use, greater than 1, will always cause it to increase. Even a negative number will get bigger, even if it doesn't get closer to positive infinity, which is some people's weird definition of bigger or greater, which I disagree with, to be honest. 17A is to factorize 6x squared minus 5x minus 4. So this is something I really haven't done, I don't think, since high school. It's going to be 3x plus or minus something, and it's going to be 2x plus or minus something. We need the 2 to multiply to minus 4, and then we need them to, so we're going to have 2x times this and 3x times this. So it's going to be positive and negative. I mean, to get to 4, we only really have 2 times 2 or 4 times 1 in terms of assuming that these answers are going to be integers, which they sort of have to be. So we can just sort of consider, can't we? If it was 2 and 2, could we ever get 5? No, we couldn't, because we're always going to end up with even numbers, aren't we? So it has to be 4 and 1. And because it's negative, it means that your negative one has to be bigger. So it's going to be, is it going to be, yeah, I think just to sort of, this is not the best way to do this, but that's sort of how I've got the, let's just double check. So minus 4 times 2 is minus 8, and then 1 times 3 would give us 3x. So that's 3x minus 8x is minus 5x. That's minus 4, that's 6x squared. Yep, I'm perfectly happy with that. I'll put brackets around it to indicate it's my final answer. I think that is honestly how you would probably do it in an exam, even though it's not the best way to do it. Hence, or otherwise solve 6x squared minus 5x minus 4 equals 0. So what we've discovered from this, what we factorized here, is that these are the zeros of this equation here. So f of x, yeah, so we can just solve it basically. We can just say 3x minus 4 equals 0. That would mean that 3x equals 4, and that would be divide both sides by 3, x equals 4 over 3. That's one of our roots of our quadratic equation, and then we can say 2x plus 1 equals 0. So that would be 2x equals minus 1, subtract 1 from both sides, divide both sides by 2, x equals 1 over 2, minus 1 over 2. So yeah, that would be, there are two roots of that equation. It's a positive quadratic, so it's U-shaped. So when is it smaller than 0? It's in between those two roots. So 6x, this is going to be our final answer. 6x squared minus 5x minus 4 is smaller than 0, where, and it's going to be x is greater than minus a half and less than 4 over 3. That's the end of question 17. So we've got 34 minutes left. I really hope we are getting towards the end. It can be useful in exams to go to the end right at the start and see how many questions you've got. Spinner A and spinner B are each spun once. Probability that spinner A, says P A red, is equal to 1 over 4. And the probability that spinner both P A and B go on red is 1 over 24. Work out the probability that one spinner lands on red and the other spinner does not land on red. So we're going to assume the spinners are completely independent, i.e. the result of spinner A does not affect the result of spinner B. So to get both of them to land on red, you would need to, so we can say P A B red is equal to P A red times P B red. We need to find PB red to do any sort of probability calculations. So PB red is equal to, we can divide both sides of the equation by PA red. PAB red divided by A red. So this is going to be 1 over 24 divided by 1 over 4. So we need to sort of figure this out. So the denominator of the denominator comes up to the top, and the denominator of the numerator goes down to the bottom. So it's going to end up being 1 times 4 divided by 1 times 24. So it's going to be 4 over 24 or 1 over 6. So working out the probability that one lands on red and one doesn't, we've got to consider first probability that A is on red and B is not red. Like this. That's not red. I'll use a dash. And that's going to be A red's 1 over 4, B not red. Obviously, the two possibilities are red or not red. They have to add to 1. So from this, it's going to be 5 over 6. Oh, for some reason my monitor seems to have disconnected. You'll have to give me a second. Imagine in the context of the exam that I've just started a sneezing fit or something, and that's why I've had to sit here and not work on the questions for a minute. There's my creative interpretation of what's just happened. Okay, so 5/6, and then P. We also need to consider the case where A is not red and B is red, and we know that P A red is 1/4, so for it to not be red is 3/4, and then P B red is 1/6. So I should have actually continued with this thing first, shouldn't I? 1/4, 5/6. If you multiply two fractions, you just multiply the numerators and the denominators, put them back together. So it's going to be 5/24. And then this is going to be 3/24. These are our two possibilities that lead to the condition we've been given, i.e. one red, one not red. So P, one red, one not red, I'll use an apostrophe to mean not, is equal to 8/24. And that is the final answer to that question. So put it in brackets. Okay. Is there a question 19? I feel there will be. Yep. Question 19. Here is the graph of y equals sine x for x between -180 and +180. Use the graph to find the solutions of sine x equals 0.3 within that range. So, again, this is sort of a pencil and ruler question. And so, again, I think I'm perfectly doing what you could do in the exam, to be honest. So, there we go. So, solutions of, that just means, okay, where is sine x, i.e. the function, equal to 0.3? And when we say equal to, the output of a function on a graph is y. So, almost exclusively. So we just need to draw a line at y equal 0.3 and see where that intercepts our curve. So y equals 0.3, 1, 2, 3, go across them there. We can see quite clearly there's no solutions in the negative x portion of this graph. Just double check that. Yeah, no solutions. Two solutions are here. So that's within a margin of error there. Yeah, estimates, so we don't need to go that detailed. And there. So that's going to be, just annotate these answers very quickly. So 90, and there's, oh Christ, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 subdivisions. I don't really believe my own counting there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right. 90 divided by 15 is 6, so it's 6 degrees per subdivision. This is 18 degrees here, the first solution. And then counting back from 180, 174, 168. I should just subtract 18 because that's 3. Oh no, 1, 2, 3. 3 subdivisions, 162. Do not do more maths than you need to one of these exams. 162 are our two answers. So, diagram. I should save that actually, shouldn't I? That's what I was literally about to do. This is 19A. Q19A. Okay. 162 and 18. That makes sense. They should be symmetrical. They should be both 18 degrees away from the zeros. Saved as Q19A.png. Solutions would be x equals 18 18 degrees, or 162 degrees. And that should be in, and this is 19A. I need to relabel this in a minute. 27 minutes left. Not stressing that I'm not going to finish the exam, just I think I've done it slower than I would do because of commentating over it, to be honest. Write down a value of x such that sine x plus 20 equals 0 for 180, between 180 and 180. So this is basically saying if we shift by 20 degrees the sine function. Now, it's a bit of a confusing thing, but if we say plus 20, we're actually shifting it to the left, i.e. in the negative direction. And that's because we're basically saying rather than giving me the output of sine now, give me what the output will be in 20 degrees. So you can basically imagine shifting the whole graph 20 degrees to the left. And so the zeros right now are minus 180, 0, and 180. So the new zeros, this will get shifted off the graph, so that doesn't exist anymore. This will become minus 20, and this will become 160. And we're going to go for the sort of first solution we see. Solution. I'll just sort of do a little bit of reasoning, even though it's a 1-mark question, so I don't need to. X plus 20 shifts graph left by 20 degrees. Don't say left. In the negative x direction by 20 degrees. Current zeros are minus 180, 0, and 180. New zeros are minus 200, minus 20, and 160. But that was 200 is not in the range they've asked for. So first zero in range is x equals minus 20 degrees. And that should be bracketed. Okay. Question 20. How many questions does this exam have? I'm really curious now. 21, 22, and that's the end, right? Okay, great. 20. Here's triangle ABC with these given lengths. Find the size of angle ABC. You must show all of your workings. So we need to use the cosine rule. So that would be, that's just 20, there's no part A or part B. A squared plus B squared equals 2BC cos A. Now, lowercase letters, A squared, oh no, sorry, that's miles off. So it's A squared equals B squared plus C squared minus 2BC cos A. I don't know where I sort of was getting that weird sort of, I don't know, different formula. That's probably not even true. Lowercase letters are side lengths, uppercase letters are angles, and a given angle, so A will be opposite the side A there. So we're trying to find the size of the angle ABC. So we'll label this as capital A, and that means that this is lowercase a, and it's then irrelevant which one's B or C because it's never actually dependent because multiplication and addition are both commutative, so it's fine. So we're looking to isolate this term. So we're going to do, first of all, subtract b squared and c squared from both sides. A squared minus b squared minus c squared is equal to minus 2bc cos A. Now, ideally, wouldn't have that minus there, so we're going to get rid of that as well. So we're going to end it with b squared plus c squared. Multiplying both sides by minus 1 is what we're doing here. Minus a squared is equal to 2bc cos A. And then we go divide both sides by 2bc. So it's going to be b squared plus, I really hope this maths isn't too annoying when I actually have to put this all together. A squared divided by 2bc. And that's equal to cos. Cos A, I just realized I have to know some exact values here, don't I, clearly, to get this answer correct, and I'm not sure if I still do. So that means that A is equal, in this case it's going to be, A is equal to cosine minus 1 of this whole fraction, b squared plus c squared minus a squared, all divided by 2bc. Will that even render properly? Yes, it will, thank God. So that's cosine, inverse cosine of, let's think about this now. So we said b and c were these two, didn't we? So that's to be 10 squared plus 5 squared minus a squared. So a squared 5 square root 7. So square root 5 gets you 25. Square root 7 gets you 7. So it's 7 times 25, which is 175. Yes. And then divided by 2bc, so that's 2 multiplied by 10 multiplied by 5. This shouldn't be that bad, honestly. So 100 for 10 squared, 25 minus 175 divided by 2 times 10 times 5 is 10 times 10, 100. That feels wrong. I don't care. You know what I'm talking about. It's not. It's good to have very clear working out, by the way, in an exam, so that you don't end up losing marks for weird looking working out. 100 plus 25 minus 175, so it's 125 minus 175, so it's minus 50, and that's over 100, which now looks as it should do. And that's just going to be minus a half. So when is cos equal to minus a half is a very, very good question. It's steep early on, so it means that it's probably... that's the wrong way of thinking about it, actually. I don't know the exact value, so I'm going to have to just sort of think about the what the cos graph looks like. So minus a half, so it goes from 1 at 0 down to 0 at 90, down to minus 1 at 180. So it's very steep in the middle bit, so it's going to be 30 degrees. If you think about how the sine graph goes from 0 to 30, and that goes to half there, it's going to be 30 degrees back from 180, I think. So I think it's going to be 150. And that makes, in this context, 150 very much makes sense, even though it might not look, it looks more like 100 degrees, doesn't it? No, because it's steepest in the middle, so surely it would go, yeah, it's steepest in the middle, so it would go down, it'd be 30 degrees after 90. So it's 120 degrees, yeah. ABC, you should know your exact values. You shouldn't have to do what I just did there, which was just sort of weird deductive reasoning. ABC is 120 degrees. That's my final answer. I think it's correct. I could have made a little slip up. I don't know. We'll find out. It sounds reasonable, so there's that at least. 21, and this is one with multiple parts. On the grid, draw a graph of this equation. So x squared plus y squared equals some other number is the equation of a circle, and specifically this number is the radius squared. 169, you should know, part of the sort of basic knowledge of this exam is 13 squared. So it's a radius 13 centered on 0, 0. I'm doing it with the circle tool. I would be doing this with a compass, and I would go, okay, here's 0, 0, here's 13, which would be very specifically 1, 2, 2.5. Yeah, it's like here. And I would then use my compass to draw a circle. And so again, given that I've outlined what the method would be, I don't think there's any, I think that's or whatever. It's obviously clearly a bit easier than it would be in the exam, but given I can detail to you what I would do in the exam and get the answer correct, I think it's fine. You might have to have multiple goes with a pencil. There'll be an allowance, obviously, because using a compass is never perfect. Let's just double check these are all in the rough correct area. Yep, yep. Yeah, okay. I accept when I shift it like that. So let's recenter everything. That's 13. I mean, we'd have other problems like this in the exam, wouldn't you? So there we go. Okay, there you go. There's my circle. Question 21A. Feels relatively easy for a 21A question. But there we go. Sometimes the hardest questions are actually 18, 19, 20-ish. Use your graph to find estimates of the solutions of simultaneous equations. Simultaneous equations on a graph, the solutions were the two or more curves that you have intersect. So we're going to go for question 21A. And we're going to draw the other graph we were given, 2y equals 3x, and we're going to see where it intersects. So 2y equals 3x, want it in y equals mx plus c form, do it to make it easy to plot, so that's y equals 3 over 2x. So that's got no y, it's got no plus c, so it'll go straight through the origin. I'll do this in blue, because now you have a blue, maybe you have a blue pen in the exam. I think you can, I don't know if you can fill them in with blue pen or not. And it's going to have a gradient of 3 over 2, yeah? Let's just double check that again. Yeah, so it's gonna, you can just draw some points it's gonna have. So x equals 2, y equals 3, so it's about there, and x equals minus 2, y equals minus 3, so about there. And then we can just use those as, along with the origin obviously, as a guide of how to plot our main, as our line. We can just, as long as we keep extending it like at the same gradient, as long as it keeps going through all of these, it's, yeah, it's estimate, isn't it? It's estimates, yeah, perfectly fine. So just need to find the coordinates of these 2 points. So this is, it's 2 and it's 5 in between, so it's 0.4 per subdivision. So minus 7.6 minus 7, let's say minus 7.5, and then the x would be minus 10 minus 10.4 minus 10 point, I'm going to say minus 10.7 is probably the closest to what that actually is. And then up here, it's identical, isn't it? It should be 7.5 and 10.7. Yes, I don't see any reason why that's not the case. It should be, yeah, it should be symmetrical around the origin. So 7.5, 10.7. Yes, okay. So I can just quite easily now say x equals plus or minus, forgotten the numbers already, 7.5. Y equals plus or minus 10.7. I will double check again that they are the figures, but I'm pretty sure. 7.5, 10.7, yeah, okay. No, that's not the way you should write that actually. You should write x equals 7.5, y equals 10.7 to make it very explicitly clear that these are the distinct pairs of correct answers, because you don't want them to think that it's positive with negative, negative with positive. X equals minus 7.5, y equals minus 10.7. Like that, yeah. So make sure the answer is very explicit, as I've done there. 22, last question of the paper, 14 minutes left. Not the pace I would have liked, to be honest, but there we go. The second term of a geometric sequence, so I'll say I'll say t2 is equal to 3 plus 2 square root 2. The third term is 13 plus square root, sorry, 9 square root 2. And we're being asked to find the common ratio. Yeah, so a geometric sequence is one where to go from one element to the next, you multiply by some constant. And we're just being asked to find that constant. So we could really just write in if we say the constant is k, which is a nice useful one we use quite often, 13 plus 9 square root 2 is equal to k times 3 plus 2 square root 2. And before going into this question, I really don't know how I'm going to answer. I'm just going to see where normal maths takes me, to be honest. 9 square root 2 is equal to 3k plus 2k square root 2. Now, is it just obviously the case that 3k is no, it's not that simple, is it? What am I missing? That we it is that k is some, it's got some a and b factor. Yeah, we've even told, okay, it's going to be a plus root b, right? So we're going to actually, sorry, I'll go back one step. I'll say k equals a plus square root b, and therefore we have 13 plus 9 square root 2 is equal to a plus square root b. multiplied by 3 plus 2 square root 2. Okay, so leaving this all the exact same on this side, we now just expand these brackets. So 3a plus, I'm just going to do, I don't know, some sort of disjointed 3 square root b, and then we're going to do second term, so 2a square root 2 plus 2 square root 2 times square root b. Now, if we have two square roots multiplied together, it's just going to be whatever these bits inside are multiplied together. So to simplify this, 13 plus 9 square root 2 is equal to 3a plus 3 square root b plus 2a square root 2 plus 2 square root 2b. Now, b has to be 2 because we're going to be left over with this 3 plus square root b term. There's no other square roots here. Does b have to be 2? Maybe it doesn't. Let's before I confidently declare that, let's just continue actually. I think it has to be, but there could be some weird thing where it ends up being another square number, like it could be 8. Yeah, it could be 8 actually as well, for example. Let's not get ahead of myself. Is there any way of working this out where I don't just assume b is? This is an irresponsible way of doing this, but I could say, let's check the b equals 2 case, right? And I'm going to have 13. There shouldn't be an equals sign at the start of this maths here. I think it has to be either 13 or 8. So 9 square root 2 equals 3a plus 3 square root 2 plus 2a square root 2 plus 2 times square root of 2 times 2, which is 4. Square root of 4 is 2, so 4 on the end there. And that would then be 3a plus 4 as the non-square root terms, and then 3 plus 2a square root 2. And does that lead us to an answer that can make sense? So 3a plus 4, so let's say 3a plus 4 equals 13. So that's 3a equals 9, a equals 3. Does it also work with the other one? 3 plus 2a equals 9. So that would mean 2a equals 6 and a equals 3. Yeah, so it's self-consistent. There's definitely a better way of doing that, to be honest. I didn't find it. So that's a, so we'll say k is such that, yeah, k is 3 plus square root 2. Okay, and that is the end of the paper, isn't it? Yeah, so I will press pause. So 8 minutes 43 seconds. So it took me an hour and 21 minutes and 17 seconds. So I definitely was delayed by commentating over this because I think I would normally finish one in like an hour. If you've made it this far into the video, you must be insane. And I'm going to leave this video here. And the next, probably considerably shorter video will be me going through the mark scheme and seeing what my final mark is for the paper out of 80. So yeah, I will probably link that next video or put it in a playlist or something. But yeah, thank you for watching and goodbye.